next we will see another problem. A survey of 320 families with 5 children each reveal the following information. Number of boys is 543210 and number of girls it is 012345 and number of families are given that is 14, 56, 110, 88, 40, 12. Is this result consistent with the hypothesis that male and female birth are equally probable? So here we are taking 320 families. In each family, 5 children are there. Either the children may be a boy or a girl. Suppose in a family, if there are 5 boys, definitely the number of girls will be 0 because we are considering a family with 5 children. And here, if we are having 5 boys, definitely the number of girls will be 0. Similarly, if we are having 4 boys in a family, definitely you will have a girl child. Similarly, 3 boys, 2 girls, 2 boys, 3 girls, 1 boy, 4 girls. And if there are 0 boys, then definitely in a family there will be 5 girls, right? So, according to this, the number of families are also given. The number of families having 5 boys and 0 girls is 14. And the number of families having 4 boy children and 1 girl children is 56. Similarly, 3 boys with 2 girls. The number of family is 110. And 2 boys and 3 girls. The number of family is 88. 1 boy with the 4 girl children is 40 and 0 boys with the 5 girl children is 12. Okay, we are taking 320 families and we have examined in each family how many boy children is there and how many girl children is there. Okay, but the question is here we have to check whether the result is consistent with the hypothesis that male and female birth are equally probable. Okay, we have to check whether the male and female birth are equally probable or not. For this, we have to consider the binomial distribution you have studied in your lower classes. What is binomial distribution formula? Before entering into the problem, we have to see what is binomial distribution. The binomial distribution probability mass function is NCX P power x Q power n minus x. Okay, where P denote the probability of success, Q denote the probability of failure, N denotes it is a number of times the experiment is repeated, right? And X success, X denotes the number of success, right? In our lower classes, we have studied this distribution. This is a discrete distribution, right? And P denotes the probability of success and Q denotes the probability of failure. X denotes the number of success, right? So I'm going to define P denotes the probability of getting a male child. Okay. What is the probability of getting a male child? There are two possibilities, right? The total number of possibilities for the child may be a male or female will be 2. Okay. And favorable number of outcome is 1. So the probability of getting a male child is 1 by 2. That is my probability of success. And what is my Q? It is 1 minus small letter p, which is 1 minus 1 by 2, which is also 1 by 2. So my p is 1 by 2, q is 1 by 2. How I am defining p? That is probability of getting a male child. That is, I am considering getting a male child as a success, right? So there are two possibilities. Either the child may be a girl child or a male child. So the total number of outcomes is 2 here, and favorable number of outcome, that is getting a male child, is 1. So I am writing 1 by 2, and cube is 1 minus p, which is 1 minus 1 by 2, which is 1 by 2. So what is our p value, which is 1 by 2, and what is our q value, it is 1 by 2, right? Now I'm going to find out what is the probability of getting or male children or male children in a family, which contains 5 children. Okay, in a family of 5. In a family of 5. In a family, there are totally 5 children. Out of 5 children, what is the probability of getting or male children? I am going to find out. So I am going to use the binomial distribution. Totally, how many children are there? It is 5. Out of 5, I have to get or male children. So I'm writing 5CR. And probability of success, probability of getting a male children is 1 by 2. 1 by 2 power R. And then what is Q? It is also 1 by 2. 1 by 2 whole to the power n minus x. That is the formula. What is my small letter n, which is 5? 5 minus R. And R can be either 0 or 1 or 2 or 3 or 4 or 5. Either it can be 0 male children or 1 male children or 2 or 3 or 4 or 5. So, probability of getting or male children in a family of 5, okay, which is nothing but 5CR, 1 by 2 to the power R, 1 by 2 to the power 5 minus R. Why we are putting 5 here? Because we are considering a family with 5 children. Out of 5 children, the probability of getting or male children, which is equal to 5CR. The probability of getting a male children is 1 by 2 whole to the power R. Probability of not getting a male children is 1 by 2, which is Q, whole to the power n minus x, which is 5 minus R. So this is the probability for a family having or male children. Totally, we are taking how many families? We are taking 320 families. We are taking 320 families. So, out of 320 families, we have to calculate the expected frequencies. So, how to calculate the expected frequencies now, right? So, number of families having or male children or male children is equal to, okay, you have to multiply the probability. What is your probability? It is 5CR 1 by 2 to the power R into 1 by 2 to the power n minus R. This is your probability of getting a or male children in a family. But here we are taking how many families? 320 families. So you have to multiply this probability by 320. So I am going to multiply this probability by 320, where R can take the value either 0, 1, 2, 3, 4, and 5. Is it clear? So I'm going to write the expected frequencies, right? Observed frequency, we know. What are the observed frequencies? We are having 14 families, 56 families, 110 families, 88 families, 40 families, and 12 families, right? Having how many male children? This is 0, right? Sorry, this is 5. 5 families are having, sorry, the number of boys in this family. 14 families are having 5 male children. The male child is 5, right? So we are having 14 families with 5 male children, 56 families with 4 male children, and 110 families with the 3 male children, and 88 families with the 2 male children, and 40 families with 1 male children, and 12 families with a 0 male child. Right? This is our observed frequency. It is given in the question. Now you have to find out the expected frequency. How will you find out the expected frequency? Already I told you, you have to multiply the probability by 320. 320 into 5CR, 1 by 2 to the power R, 1 by 2 to the power n minus r, which is 5 minus r. And r can be either 5, 4, 3, 2, 1 or 0. Suppose if we are taking r is equal to 5, this is my r value, right? If r is equal to 5, 5c5 which is 1 by 2 to the power 5, 1 by 2 to the power 0 which is 1, right? So 320 into 1 by 2 to the power 5, because 5c5 becomes 1. 1 by 2 to the power 5 you will have, this becomes 1. So 320 into 1 by 2 to the power 5. You can do it in calculator itself. So you are getting the value as 10. Not 10. Yeah, it is 10. Right. And then 320. Next, R value is 4. That is 5C4. In calculator, you just simply type 5C4. So you will get one value into 1 by 2 to the power 4 into 1 by 2 to the power 1. So you will get the value as 50. And then if R is equal to 3, you will get 100. If R is equal to 2, you will get 100 again. If R is equal to 1, you will get 15. And if R is equal to 0, you will get 10. This is our expected frequency. Then what we have to find out? Another column, that is OI minus EI, the whole square divided by EI. This column we have to find out, right? So as usual, that is 14 minus 10, which is 4 square divided by 10, which is 1.6. The next value will be 0.72, 1, 1.44, 2.4. If you add this value, you are getting 7.16, right? So my calculated value of chi-square is 7.16. And in step 3, we have to find out the table value. Already I told you the degree of freedom is n minus 1. Here we are having 6 values. So 6 minus 1, which is 5. The table value for 5 degrees of freedom at 5% level of significance is 11.070. In chi-square table, you can see across 5. The degree of freedom is 5, right? So you can see under the chi-square table. And in step 4, you compare these two values, that is calculated value as well as the table value. The calculated value was less than the table value. Therefore, we are accepting H naught. What is our H naught? That is male and a female both are equally probable. So we are accepting that one. That's all. Thank you.